Okay, welcome back to the 4.2 notes. We're going to do the first derivative test on question number 44. And this is one of my favorite functions. And the reason why this is one of my favorite functions is because not only do we have an x squared in here, but we're multiplying that by a natural log function, okay? So, there are a lot of things to consider here, and so let's get started. But the first thing I want to talk about is this natural log function, and I want to talk about the graph of that function and a couple points on that graph real quick. So what I'm going to do is I'm going to come in here and I'm going to draw the graph y equals the natural log of x, okay? And so if I draw the graph of that, it's going to look like this. I know that I have the point 0, 1, okay, on that graph. I also know that I have the point E1 on that graph, okay? And I know that I have the point 1 over E and then negative 1. Okay, so if I have all those points together, I end up getting this from my natural log function. Okay, we get a function that looks like this. And so the one thing I know about this function is that it's asymptotic to the y-axis. Okay, it will never cross the y-axis. And it just continues to go on in this direction forever and ever and ever. So the one thing I do want to talk about is the domain of this. Okay, the domain of this function is from 0 to positive infinity. Okay, and the reason why I'm writing that down is because we have to consider the domain of this function. Okay, now when I look at the x squared part, the domain of that function is from negative infinity to positive infinity. Okay, this is a polynomial. I have x value, or I have y values at every single x value. Okay, but the natural log function I don't. Okay, I'm restricted. I'm restricted to only positive numbers for x. Okay, I cannot have x equals 0, and I cannot have negative numbers for x because I don't have any y values, okay, on this side of the graph. So that's my domain, and I just kind of wanted to talk about that before we tackle this problem because I'm going to come back to this, and I'm going to use this to help us answer all the questions we have for the first derivative test. So let's go ahead and get started. And for the first derivative test, I want to take the derivative. Okay, so I have this function x squared. I'm going to call that u. I'm going to call the natural log function v. Okay, I'm multiplying these two. So in order to take the derivative, I have to use the product rule. So I'm going to let u here equal x squared, and v is equal to the natural log of x. And so then the derivative of u with respect to x, u prime, is going to give me 2x, okay? And then the derivative of v with respect to x is equal to just 1 over x, okay? And then I cross multiply and then I add, okay? So f prime of x is equal to 2x times the natural log of x, and then plus x squared times 1 over x, all right? So, and this is my derivative. So f prime of x, let's simplify this a little bit, is going to give me 2x times the natural log of x. And then I'm going to multiply these two functions, and I get x squared over x. Okay, and this just simplifies down to just x. Okay, x squared and x divide out to just give me an x. So I get f prime of x is equal to 2x times the natural log of x plus x, okay? And this is simplified, okay? I can't go any further than this. So now what I want to do is I want to take my derivative and set it equal to 0, okay? So if I set 0 equal to 2x times the natural log of x plus an x, okay? Now I need to solve for x. So what I'm going to do is I'm going to factor out an x, okay? That's the only thing that I can do. I get 0 is equal to x times 2 times the natural log of x plus 1, okay? And so now I have two factors here. I have x and I have 2 times ln x plus 1. So I'm going to set each of those equal to 0, so I get x equals 0, and I get 2 ln x plus 1 is equal to 0. Okay, so I know that x equals 0 is a critical point, but what do we know about our function for natural log? Okay, that function, the y value, does not exist at 0. Okay, my domain does not include 0. So x equals 0 is not in our domain. This is going to be very, very common. Okay, so I'm going to zoom back in, and I'm going to write that this is not in our domain. Okay, not in our domain. All right, so let's go ahead and take a look, and let's solve this equation. Okay, 2 ln x plus 1 equals 0. So I would do this. I'm going to zoom in, and I'm going to do, let's do 2 ln x plus 1 equals 0. All right, so if I subtract 1 from both sides, I'm going to get, I'm going to get 2 ln x is equal to negative 1. If I divide by 2 and divide by 2, I'm going to be solving this equation. Okay, so now I've got the natural log of x is equal to negative 1/2. Okay? Okay, so the only way to solve this equation is to change the natural log of x into our log function. Okay, I'm going to write this as log base e of x is equal to negative 1/2. Okay, and what I want to do is I want to get this out of log form. Okay, and so what I'm going to do is I'm going to take my e here. This is my base, and it's supporting the log. Okay, and I'm going to take my e and I'm going to shove it up underneath my negative 1/2. This value here becomes my new exponent. The log drops off into the abyss, and we are left with that x is equal to e to the negative 1/2 power. Okay, so that's kind of powerful. All right, and the reason why that's powerful is because even though that kind of looks a little weird right now, okay, I can just rewrite this as x is equal to 1 over e to the 1/2 power, the positive 1/2 power. But we know that this is just the square root of e, okay, so, or 1 over the square root of e. So x is equal to 1 over the square root of e, okay, and this is a positive number, okay, and so because that's positive, I know it's in our domain, okay, because we can only have positive numbers. Okay, so now what I'm going to do, I know that this is my critical point, okay, and I know what my domain is, so I'm going to use my critical point, and I'm going to use my domain that we have. Oh, wow, lots going on. Okay, I'm going to use my critical point in my domain to set up my first derivative test. Okay, we're going to need to remember what our derivative is, and then we're going to use that. Okay, so let's go ahead and let's zoom back in up here, and I'm going to write out what we need for the first derivative test. And I'm going to write the word interval. Okay, I'm going to write the word sine of f prime. I'm going to write the word behavior of f. Okay, and so let's go ahead and draw in my intervals. We start at 0. Okay, I just got to look at my domain. I start at 0 and I end at infinity. But in between there, I have the critical point of 1 over the square root of 3, which we just found. Okay, so I'm going to go from 0 to 1 over the square root of e. Okay, and then I'm going to go from 1 over the square root of e to infinity. Okay, and we're going to test some points here. And so here's what I want to do. Okay, here's where it gets kind of tricky because we're doing this without a calculator, guys. Okay, and so I need to think about the points that I'm going to test in my derivative. Okay, and I have to think about a value between 1 over the square root of e, okay, and 0. Okay, something that's really, really small. Okay, and so there's a number of ways to think about this, but I know that I can use the point 1 over e. Okay, I'm going to zoom in on this. I can use that value 1 over e. And let me kind of rewrite that so it looks nice. This x value right here is 1 over e, okay? Now, I know that 1 over the square root of e is further up in between 0 and 1, okay? That value that we got, 1 over the square root of e, is my critical number, okay? So I want to choose a value between 0 and 1 over the square root of e, and that one that I know is just 1 over e, okay? And so that value, that y value is -1. So let's go ahead and plug that in to our function, or to our derivative, and see the sign that we get, okay? So I'm going to choose the value 1 over e. Okay, and we'll talk more about this problem. We'll do this problem in class, but I really just like this problem because it's really it takes a lot of knowledge to be able to do this one. This one's pretty slick. So anyway, if I plug that into my derivative, 1 over e, then I'm gonna get this. Okay, I'm gonna do f prime of 1 over e, and that's gonna give. And I'm just worried about the sign here. I just want to know if we're gonna get a positive number or a negative number. So I get 2 times 1 over e, okay, times the natural log of 1 over e, okay, and then plus 1 over e, okay, plus 1 over e. So now here's what I want to do, okay? So the one thing that I do know is I do know that the natural log of 1 over e is equal to -1. Okay, and I know that because I have that on my graph up here, all right? It's the y value of -1. So I'm going to go ahead and plug that in, and so we get 2 over e times -1 plus 1 over e, okay? And so if we simplify this a little bit, it may be hard to see what exactly your value is going to be, but this is going to be -2 over e plus 1 over e. And if I take -2 and add 1, that's going to give me -1. And we keep our common denominator of e. Okay? So I know that my sign on this interval is negative. Okay? Therefore, my function, okay, is decreasing. All right? Now, let's go ahead and let's take a look at the interval between 1 over e and infinity. And I'm actually going to choose the value of e, okay? And the reason why I'm going to choose the value of e is because I know what the value is on that graph. Okay, so if I go back over to my graph, I know I have the point e1. Okay, so if I plug in e into my natural log function, I'll get 1. Okay, so now let's go ahead and do that. And I'm going to do f prime of e is going to give me 2 times e times the natural log of e plus e. Okay, so I get f prime of e, and that's going to give me 2e times 1 plus an e. Okay, I'm taking a positive number plus a positive number. So I know that my value here is just going to be, well, it's going to be 3e. Okay, but that's just going to be positive. Okay, and that's what I'm looking for. All right, so go back up to my table, and I put that this is positive here. Okay, so therefore, I know that my function on that interval is increasing. Okay, so what I'm going to do is I'm going to go ahead and graph this function, and then we're going to kind of analyze it a little bit and see what we can tell about this. Now, the one thing I do know about this, one thing I do need to clarify, is that because our graph f decreases over the interval between 0 and 1 over the square root of e, and then switches to increasing at 1 over the square root of e, we have a minimum value here. Okay, so I'm going to write that in, that we have a minimum. Okay, and so we can kind of also generalize that it's going to be an absolute minimum because our graph is strictly decreasing and then strictly increasing. Okay, so let's go ahead and look at the graph of that. All right, so there's our graph, and the one thing I want to talk about here is that if you look down here, okay, here's our minimum value, okay, and I typed in the value 1 over the square root of e on my Desmos app and got a value of 0.6065, okay, and this has been rounded to 0.067, or 0.607, sorry, 0.606. And we got a minimum value of negative 1.184, okay? And we can actually calculate this value given our function. Let's go ahead and do that. So I'm going to come in, let me zoom in here so we can see it. But I'm going to go ahead and do f of 1 over the square root of e. I'm going to plug that back into my original function to see what y value we get. Okay, and so I'm going to do the quantity 1 over the square root of e squared times the natural log of 1 over the square root of e. Okay, and so this is kind of tricky to evaluate. But the one thing that I can do here is, let me do this. I'm going to do, if I take this first part, 1 over the square root of e, and square it, okay, I get 1 squared, and I get the square root of e squared, which is just going to give me e. Okay, so I'm going to get 1 over e times the natural log. And I'm going to rewrite this 1 over the square root of e as e to the negative 1/2 power. Okay, so I'm going to rewrite this as e to the negative 1/2 power. Okay, and the reason why I did that is because I can take this negative 1/2 and kick that up front in a log function. So I'm going to get this. I'm going to get 1 over e times negative 1/2 times the natural log of e. Okay, and the natural log of e is just 1. Okay, so this is pretty nifty. To get an exact value, I'm going to get negative 1 over 2e, okay, which, if you plug that into your calculator, will end up giving you negative 0.184. So just something that you can do there. But we do want to calculate that. And so, but the important thing is we've got to answer the question, okay? This is our absolute minimum, okay? Absolute minimum. Okay, we can tell by the graph. Okay, we can tell that it's down here. Okay, and that's the value that we get. But we can also tell by using the table, okay, that we decrease and then we increase. So, you know, guys, this is a pretty hard example. Okay, this is kind of, I would say, algebraically, probably one of the hardest problems that we will do. But trust me, if you can understand this and you can do it, then, you know, you're going to be doing a great job. So hope you enjoyed this. I hope you had as much fun as I did. I absolutely love this problem. This is one of my favorite problems, and I'm really happy that we're doing it finally. So get used to it. We're going to do a lot more of this. It's going to be fun, and that's non-negotiable, okay? We're going to have fun.